All right, guys. This video is going to be about Module 0.10b, Dimensional Analysis and Units in Context. So the first problem has the distance formula. So distance equals the velocity times time. So d equals v times t. So it says if the units for v are centimeters per second, I'm going to go ahead and highlight that. So v is centimeters per second. And then t, the units for t are seconds. So I'm going to put that right here. And it says, what are the units for distance? So the first thing I want to do is set this up basically using the words, but we don't know what words to use for distance, so we're just going to let it be d. So if the units for volume are centimeters per second, so instead of volume, I'm going to put centimeters per second. And the units for time is seconds. So instead of the t, I'm going to put seconds. Now, just like everything we've done in dimensional analysis so far, when you have one in the numerator and one in the denominator, it cancels out. So every whole number is over 1. So you could think of this as a top variable, seconds. So we have seconds up top, seconds on the bottom crosses out, which means that your distance is measured in centimeters. All right, so our second one. This is acceleration. So we're trying to figure out what are the units for A. So we know volume is meters per second. We know that time is measured in seconds. So now when you have divide by t, anytime you have like divide by 4, it's the same thing as taking a quarter of it, so multiplying it by 1/4. When you cut something into 2 pieces, you're splitting it in half. So I'm going to change this divide by t to times 1/t. And that's just to help out with the visual part of this. So when you're dividing by something, is the same as multiplying by 1/, that amount. So when we come down here to do our rewrite, we have A equals, instead of volume, I'm going to put meters per second. Instead of time, I'm going to multiply by that 1/t. Oh, sorry, our time is in seconds. So time is in seconds, so it's not 1/t, it's 1/s, because I'm replacing this t with an s. So now you multiply fractions straight across the top. So we have meters times 1, so that's just meters. And then we have seconds times seconds, so that's seconds squared. So that means we're going to measure A, the acceleration, as meters per second squared. So the next one is a little bit tricky because we're not, on the first two, we had D equals, so the distance equals. And then we had A equals, so acceleration equals. On this one, we know what C is. So we're going to rewrite this again the same way we did the other two. So we have C is your calories. So I'm going to go ahead and write that. Calories equals, tells us M is for pounds, and then it also tells us T is for minutes. So we're trying to figure out K, so we want to leave it as K. So we have K, M is our pounds, and then T are the minutes. So now, in order to get any variable by itself that's being multiplied by other things, we have to divide it. So in order to solve this one, we've got K times pounds times minutes. So to get K by itself, we have to divide by pounds and minutes. So on this side, we have to do the same. Pounds, going with a thinner marker. And minutes. So pounds crosses out, minutes crosses out, and it leaves us with the K is all that's left on the right side. So K equals calories per pound times minutes. And you can leave it just like this one because this one's not as easy to translate into a single phrase. So the K is the calories burned per pound times the minutes. So number 4, I'm going to let you guys do on your own. Same with number 5 since it's multiple choice. So we're going to do number 6 next. So it says convert 60 miles per hour to feet per minute. So this is the same thing we were doing on the other paper, the 0.10a. So this is kind of just a recap. So we're given that it's 60 miles per hour. So that's the first thing we want to put, 60 miles per 1 hour. And if you like the fraction thing, you guys can do the fraction thing. I just prefer the table because you'll see it again when you get to chemistry. So we want miles to change to feet. We know how many feet are in a mile. So miles is up top, so miles has to be at the bottom. And there's 5,280 feet in 1 mile. So then we still have to change hours into minutes. We know how many minutes are in an hour, so hours is at the bottom, so that means hours has to be at the top. So 1 hour is equal to 60 minutes. So now we multiply straight across the top. So 60, we got to cross out our units. So miles at top, miles on bottom. Hours on bottom, hours on top. We're left with feet per minute, which is exactly what we want, feet per minute. So now we can multiply our units. So 60 times 5,280 times 1, those are all those numerator values, gives us 316,800 feet, because that's your units at the numerator values. And then 1 times 60 gives you 60, and the only units we have left at the bottom is minutes. So when you divide 316,800 feet by 60 minutes, you get 5,280 feet per minute. So we're also going to do number 7 together. So number 7 says 1 gallon every 5 miles is how many dollars per day? So our given information, 1 gallon every 5 miles. So I'm going to zoom in so I can write smaller. So 1 gallon per 5 miles. And it says we want to get it down to dollars per day. So we're going to have to transition through all this information in this little rectangle in order to figure out the dollars per day that is 1 gallon per 5 miles. So we have gallons and miles as our given unit. So I see miles here, so that's the first one I'm going to use. So 1 hour is 55 miles. So miles is at the bottom, which means 55 miles has to be up top, and 1 hour at the bottom. So that takes care of the miles. Miles are gone now because 1 up top, 1 on the bottom. So now I have gallons and hours. So my next one says 1 gallon is $3.10. So gallons is at the top, which means 1 gallon has to go at the bottom. And we have $3.10. Last but not least, it says one driving day is 10 hours. So I have hours at the bottom, so I'm going to put 10 hours at the top is one driving day. So hours at the bottom, hours at the top. So we're left with dollars per day. So when you multiply straight across the top, 1 times 55 times $3.10 times 10, you get $1,705. And then you multiply straight across the bottom. 5 times 1 times 1 times 1 day is 5 days. So we want to simplify this to the unit rate, so per 1 day, and we get 1,705 divided by 5 is $341 per day. All right, we're also going to do number 8 together. So number 8 says, a rectangular prism has a volume of 2 meters cubed, a length of 40 centimeters, and a width of 50 centimeters. Because the units are different on all these, that's where you have to start. So because 2 of them are measured in centimeters, I'm going to make the 2 cubic meters into centimeters. So remember, this is metric. Centimeters and meters are metric, so we can do the ladder. So we have 2 meters. So we're going from a base unit, and we want it to match the others, which are at centimeters. So we're going to move our decimal place 2 times to the right, so that 2 meters becomes 200 centimeters cubed. So now when we fill in what we know, we have the volume of a prism is what we're talking about. So when we do this, we want to start off with our formula for volume. Volume is length times width times height. So we know that the volume is that 200 centimeters. So I'm going to start there. 200 centimeters cubed equals, the length is 40 centimeters. So length is 40. So this L we're changing to a 40. It says the width is 50. So this W I'm replacing with a 50. And it says, what is the height? So I'm just going to throw an H back on the end. So when we simplify this, we have 200 equals 40 times 50 is 200H. To get H by itself, you divide by 200, which means 1 equals H. So the height equals 1 centimeter. Make sure you always include your units. All right, and number 9 seems ridiculous because we don't know what a kib, a dat, a dink, or a cham are. But this is just proving that you can convert anything as long as you know how to set it up. So our given information is first, 12 kibs, 5 dats. So 12 kibs per 5 dats. Our next piece of information says, for every 7 dinks, there are 2 dats. So dats is at the bottom, so dats has to go up top. So for every 7 dinks, there are 2 dats. The last one says, for every cham, there's 10 dinks. So dinks is at the bottom, so we want 10 dinks up top. And 1 cham at the bottom. So now when we cross out our units, we have dats at the bottom, dats at the top, dinks at the bottom, dinks at the top, and we're left with kibs per cham, kibs per cham. So now we can multiply straight across the top, straight across the bottom, and then divide. So we have 12 times 2 times 10, which gives us 240 kibs. Then for the denominator values, 5 times 7 times 1 cham is 35 chams. And because we want this in the unit rate where it's per 1, we divide those and we get approximately 6.86 kibs per cham. So number 10, I'm going to let you guys do on your own, and we're going to go ahead and flip to the back of this page, or the second page of this, and we're going to do 2 of these together. So number 11 says the width of a rectangle is the square root of 2 centimeters. But Katie has a crazy fear of crazy numbers, so she estimates it to 1.41 centimeters. The length of the rectangle is 3 square root of 2 centimeters, but Katie estimates it to 4.24 centimeters. What is the area of the rectangle? And it says calculate both decimals and radicals. So for this one, I always feel when you have a rectangle, it's easiest to draw it. So the width of the rectangle is square root of 2. The length of this rectangle is 3 square root of 2. So to find area, you multiply the length times the width. So we have square root of 2 times 3 square root of 2, which gives us outside number is 1. So outside times outside is 1 times 3 makes 3. And then inside times inside is 2 times 2, so that makes 4. The square root of 4 is 2. So if we use the radicals, we end up with an area of 6, because 3 times 2 is 6. And I forgot my units, so 6 square centimeters. So now if we do the same exact thing, but this time we use the decimals, we have a width of 1.41 and a length of 4.24. So again, area is length times width, so we're going to do 1.41 times 4.24, which gives us 5.9784 centimeters square. So at this point, we have 2 questions that follow up this work. It says, which area of the rectangle is more precise and why? So that 6 centimeters squared is using our radicals. The radicals have the more precise answer. And that's because the decimals are rounded. Decimals are rounded values, which makes them less precise. So the next thing says, if you were pouring concrete to the base of a house, which answer would you want to use and why? In this one, if you've ever done anything where you've built anything, measured anything, there are no rulers that have radicals on it. No measuring equipment has radicals on it. So this is where you would want to use the decimals instead, because no measuring equipment uses radicals. So while the radicals make more sense to keep these numbers very precise, it's very difficult to measure out something in radicals because there's no measuring device that measures things in radicals. All right, so the last one on this paper we're going to do is number 13. So the others, again, I expect you guys to use the other problems to practice, like your work session after watching this video. So that's why I'm leaving them blank. All right, the last one. I need to extend my page for this one. You guys can turn your papers crooked for it or put it on another sheet of paper, however you want to do it. You could even put it down at the bottom of the paper, down in this area, because you won't need that much room for everything else. So up here, we have Jane noticed that her faucet was dripping. She later figured out that the rate of dripping was 50 drops every minute. So there's our given information. 50 drops per minute. So she says, if 20 drops equals 1 milliliter, how many liters per year is the faucet leaking? So the first thing I want to take care of is these drops. So 20 drops equals 1 milliliter. So drops is at the top, so drops goes at the bottom. We want our answer in liters. So milliliters to liters. So we have so remember, milliliters are here, and we're going to move our decimal place to liters, which is a base unit. So 1, 2, 3 times to the left. Another way that you can think about this, instead of saying, actually, let's just keep it like that instead of looking at another perspective. All right, so we know that 1 milliliter equals, so 1, 2, 3 times to the left, 0.001 liters. So now milliliters crosses out and we're left with liters, which is our goal. So now we have to deal with these minutes changing over into years. So what do we know about minutes? We know that there are 60 minutes in 1 hour. And that takes care of our minutes. So the next measurement up from hours is days. So we have 24 hours is 1 day. And we're trying to get to years. So at this point, we can compare days to years. So hours crosses out, we're at days. So 365 days equals 1 year. Days at the top, days at the bottom, they cross out. So now, if you look at your units, we are left with liters at the top and years at the bottom, which is exactly what our question is asking us to find, liters per year. So when you multiply straight across the top and then divide by the numbers at the bottom, you end up with 1,314 liters per year that is lost by this dripping faucet. So the follow-up question asks you how many gallons a year is the faucet leaking, and it gives you the conversion. So I feel like you guys can do that one as practice as well. So again, use this video to help teach you how to do the ones that we didn't do together, and you guys need to be doing those and then checking your answers on Canvas later.